When you're in the checkout aisle of the grocery store, they usually display a bunch of things very nicely for you to just pick up and put in the trolley as you're inching forward. And inevitably you take one or two of these things home. And sometimes when it's your birthday, or it's Christmas, or you're having like a housewarming, and people don't know what to get you, they also bring you some of these things. And I'm not talking about chocolates. You basically end up with the responsibility to take care of a bunch of houseplants. And as all the memes tell us, everybody struggles to keep them alive. I'm obviously thinking, oh wow, this is a cool project. I'm just going to automate taking care of them, watering and such. And then I was like, okay, I can use the ESP32 and I can make a little web interface and set all the timing and basically, go full mechatronics engineer on this. And then I'm like, okay, well then I need a relay and a pump, and then I need to power the pump. I use solar panels. I don't want to run a cable outside. And eventually I'm just like, this could be one of those projects that just, the scope creep, it never gets done. And I was like, how simple can you make it? No electronics, no moving parts, just water needs to go from here to here in a specific quantity, obviously. To do that, you need energy. I wanted to use a solar panel, and that just seems like using the sun's energy with a bunch of extra steps. Why can't I just get the sun to move from one place to the other? I mean, it does do it through clouds, but I want to do it more specifically. So I came up with this. So you've got some water reservoir, you've got your plants, and you have to get it from the bucket to the plants. So what I'm thinking is, okay, we need to pull water from the reservoir in a certain quantity and then push it out to the plants. So let's start with 2 upside down Coke bottles and 2 one-way valves. So somehow we just need to pull the water. So now we just need to create a pressure gradient, right? A positive one and a negative one, a positive one and a negative one. Then we basically have a pump. So one-way valve into the bottles and one-way valve out of the bottles. I'm like, okay, how are we going to make that pressure? We want to use the sun because I don't want to do anything else as a free energy source. So I have a big tank that is just connected to the top of the Coke bottles. And then what happens is when it's night, the tank gets cold, the air contracts, it pulls water from the reservoir into the bottles, and then during the day when it's hot, the air expands and it pushes the water out of the bottles. And the nice thing here is that the hotter it is, the more water it pushes out.
I'm a bloody genius.
And yeah, this is how it looks. It's terrible quality photos. I didn't have any time really for this project, and I've been meaning to release this video since February, so that happened. Anyway, here you can see early morning, that's how much water it pulled in, and then later during the day when it started getting warm, you can see the water level going down as it pushes it out into the plants. It doesn't look like much water, and yeah, that's true. There's several things that affect this. Water is heavy. That means to lift it any small amount, you have to apply a lot of pressure. Like to lift water 1 meter up through a pipe, that's a lot of suction. And so how much pressure differential can you really create in a black tank between night and day? Let's say that's a 20 degree temperature difference. Well, before I started the system, I obviously wanted to see if it's feasible or not, and luckily in South Africa we have something called load shedding. So during one of those sessions I just quickly did a PVT, was it PVT equals MRMTC something equation. So sketched it out, calculated what the volume would be of the water I want to lift, how high I can lift it, and obviously it helps to have 2 bottles because then you minimize the height you have to lift it. You can lift more water by not lifting it as a height. So there are several factors here, right? I'm trying to explain this quickly, but obviously as the water gets filled into the Coke bottles, your pressure decreases in your tank system because the volume, the air is satisfied. It's crimping to the volume it wants to be. So to stop that effect, you can just make the tank very, very big. It's not going to change your pressure. You know, you're not going to lift the water a higher height, but you're not going to have that drop off of pressure as the tanks get full. So just make the tank sufficiently large, and you won't see that happening. And then also, if you look at this graph that I drew here, where is it? This basically explains the tank pressure. You can see the working range. So that is the total lowest pressure and highest pressure that the tank achieves based on, you know, the night and day temperatures. And then you have the water silo level on the horizontal axis. And you'll see that from the point that you want to lift the water out of the bucket to the height that the plants are, or the height that the bottle level is, until you've matched that pressure differential, no water is going to flow. Like, you have to pull hard enough, and then suddenly water will start flowing into that bottle. And you can see here when it's night, when the pressure is high enough to lift it out of the bucket, then it starts filling the water in, and the area underneath that triangle is how much water you're going to get into the bottle. And then similarly, when it's daytime and the graph goes the other way, that amount of water will be ejected on the other side. So how do you improve this? Well, the first thing you can do is you can just bring the reservoir and the bottles closer together, or the reservoir and the plants together. That means there isn't a big pressure differential that has to work against, and then you increase the volume of the water you can pump. The other one is obviously also to increase the temperature. So that's why the tank is painted black. If you increase the temperature, then your pressure differential goes up, and you can have a higher difference in height between your reservoir and your plants. Anyway, it works pretty well. Like, it doesn't pump massive quantities of water, and I honestly thought that it's going to break after like 2 or 3 weeks, but it's been just chugging water for the last 7-8 months, and it hasn't broken yet. So cheers, thanks for watching, and maybe I'll release another one before I die.